Alright guys, question 14. Diagram 10 shows a curve of a quadratic function. So they gave you a quadratic function here such that h and k are constant. The curve has a minimum point at t. So this is the minimum point here. Question A. Determine the range of values of x when fx is more than 0. So they said when fx is more than 0. So at which part fx is more than 0? Above here, right? These are all fx more than 0. So that means we are not going to bother about what is down here. Okay, we can ignore this bottom part. We don't care. So when we are only looking at the top here, what range of x value will exist? Well, the range of x value will exist is from here onwards, right? Correct? So in other words, x is from -2 all the way to -infinity, because here you can keep extending lah, okay? And on the right, we don't know what this point is, but the x value is going to be from this point all the way to +infinity. Okay, so this is the x range of x value. Okay, so we are going to use these two. We already know the first part here. We know the question A. We know that the first range, we know x is going to be less than or equal to -2. Okay, because it's going to be from -2 all the way to -infinity. So now we want to find what is this point. Okay, what is this point? So what we can do is, we know that the axis of symmetry, right? Axis of symmetry is always the middle between these 2 points, correct? So in other words, what we can do is we can use the midpoint formula. So we can take -2 plus, so this x value here we don't know, plus x over 2 will be equals to -1/4. Okay, so we are using the midpoint formula. So -2 plus x equals to 1/2, and x is equals to 1/2 plus 2 will be 1.5 or 3/2. Okay, so we know that this is 1.5. So the other range would be x is more than equal to 1.5. So these two are your answers. Alright, question B. Prove that k is more than this. So when you see this range here, right, you can use the formula b square minus 4ac. Now this graph here has two real roots, right, two different roots. So we can say b square minus 4ac is more than 0. Okay, so from our equation here, we can form our ABC, right? A is going to be equals to 2, B is going to be equals to H, and C is going to be equals to -2k plus 5. So B square is going to be H square minus 4, A is 2, C is -2k plus 5 more than 0. So H square, so you get positive 16k minus 40. Okay, so now we want to find k, right? So we shift the others. So we get 16k is more than 40 minus h square. Then k is more than 40 minus h square over 16. So it's proven. Okay, that's what they're asking for. Now question C. Using completing the square method, find the minimum value of the function in terms of k. So they only asking for in terms of k. So that means we have to find the value of h, because we don't know what's the value of h, right? So we have to solve that first. So from here, the equation we have, let me rewrite the equation. Equation is fx equals to 2x square plus hx minus 2k plus 5. Okay, so this is the equation that we have. So first step, we want to find the h value. So the h value, what we can do, let's see, we can actually use the, okay, since we have the symmetry here, we have the symmetry is what? -1/4. So the formula, if we have a general equation like this, we know what is the the axis of symmetry is always going to be right here. Axis of symmetry is negative b over 2a. Okay, when you have a general formula like this, negative b over 2a will be equal to the axis of symmetry. So in this case, we know that negative 1 over 4 is equal to, okay, wait, let me rewrite. A is 2, b is h, c is negative 2k plus 5. So we're going to substitute here. Negative b is what? B is h times 2, divide by 2a. 2 times 2 lah. Okay, so from here, negative 1 over 4 equals to negative h over 4. So we know that h is equals to 1. So when we know h is equals to 1, now we can use completing the square to find the minimum value. So let's do this. So fx, okay, wait, let me just write 2x squared plus x minus 2k plus 5 is okay, completing the square, right? So wait, why I write this? Sorry, my bad. Like this, 2x squared plus hx minus 2k plus 5. So first thing we want to do, completing the square, we have to make sure the coefficient of x squared is always 1. So we're going to factorize the 2 out first. Okay, I'm just going to factorize from these two lah. This one is not going to change much. Okay, so I'm not going to touch that. So I get x squared plus, by the way, the h is already 1, so no h there, so it's just plus x. So plus 1 over 2x minus 2k plus 5. Okay, now once I factorize, then I can do completing the square. So x squared plus 1 over 2x plus 1, okay, for those who don't remember, you have to plus, take this value here, so it's positive 1 over 2, so 1 over 2 over 2, 1 over 2 over 2. So here is plus, here is minus, right, so I put a different bracket, and then continue this back part here. I write down negative 2k plus 5. Okay, so now we can factorize the whatever is in here. So we've got x plus 1 over 4, then the square, just leave it up here. This x comes here, oops, this x comes here, and then this whatever you get here comes here. Okay, the shortcut lah to simplify the completing the square. So this part will become 1 over 2 over 2 will become 1 over 4, then you're going to square it, so you get 1 over 8, sorry, 1 over 16, and then you're going to expand this, you will get 1 over 8, so negative 1 over 8. Okay, I hope you know what I'm doing here. Okay, this one no more already, minus 2k plus 5. Okay, now we want to find the minimum point, minimum value. So minimum value is going to be here. This is the minimum value. So you simplify, we can get minimum value equals to, these two you combine, you should get 39 over 8. 39 over 8 minus 2k. Yeah, so this is your minimum value in terms of k. So this is your answer.